Hello, this is homework help for our pre-calculus review. Homework help for our pre-calculus review. I'm going to start on section 1.2, number 43. This is a problem that lots of people asked about, and so I just want to remind you what we're looking for. So the problem is asking us to complete the square to find the max or the min. Okay, so if we were to graph this, and that's not what the problem's asking us to do, but if we were to graph this, this is what the function would look like if we graphed it. This is what we're looking for right here, this vertex. The vertex is what's going to tell us if it's a max or min. And if you remember back from 112, we have a parabola that is the upside down u, and the reason for that is because this value right here is negative. If this value right here was positive, our parabola would be shaped like this. Okay, so we talk about the end behavior a lot in Math 112, and the end behavior for this particular graph is that they are both going down. Okay, and so this vertex right here is what we're looking for, and we're going to have a max because our a value is negative. So now the algebra behind how we complete the square with this one. So if you remember, the vertex formula for a parabola is y equals a times x minus h squared plus k. So that's the form that we're wanting to get it in. And hk is going to be our vertex. hk is our vertex. So the first thing that I'm going to do is I'm going to take this 8 and I'm going to separate it from this part right here. So I'm going to have y equals negative 4x squared plus 3x, and then I'm going to have plus 8, okay? Because I am going to complete the square of this part right here. But before I can do anything else with that, I need to go ahead and factor out that negative 4. Now, I'm not going to factor the negative 4 out of this 8. I'm only going to factor a negative 4 out of this right here. And this is what is probably confusing for factoring out that negative 4. So what I need is I need to multiply negative 4 over 1 times something, and then that whatever I multiply that times is going to give me positive 3. Okay, so I am factoring out a negative 4, and it just doesn't seem natural to factor out a negative 4 of that. But we can. So the first thing that we want to know is that we are going to want this negative 4 to cancel with something right here. Okay, so this negative 4, when I multiply it, is going to need to cancel with whatever's right here. So I am going to go ahead and put a negative 4 here. So when I multiply these two things together, the negative 4s are going to cancel. So that's all going to become 1. So then what I'm going to have right here is 3. So this is what I get when I factor out a negative 4. So I'm going to have x squared minus 3 over 4x. Okay, and then I've got my plus 8. So it's this step right here that's confusing, because remember, when I distribute this negative 4 to the x squared, I'm going to get negative 4x squared. And then when I distribute this negative 4 to negative 3/4, I'm going to get positive 3. And so that's what I did right here. I knew I was going to have to multiply negative 4 times something to give me positive 3. Okay, now I'm going to take half of negative 3/4 and square it. Okay, so over here I've got negative 3/4, and I need half of that. So I'm going to multiply it times 1/2. So that's going to give me negative 3/8. Okay, so I've taken half of negative 3/4, and now I'm going to square it. And so when I square that, I get positive 9 over 64. And that's what's going to go right here. Okay, now we have to keep our equation balanced. If I add 9/64 right here, I'm going to have to subtract something right here. Okay, I've got to keep it balanced. So if this is positive 9/64, I've got to do something right here to keep it balanced. Now, the place that students make mistakes is they think, oh, well, if I added 9/64 right here, then I just need to subtract 9/64 right here. But I didn't actually add 9/64 right here. I added 9/64 times -4. That's what I've actually done to this part of the equation. So I need to multiply -4. Let me erase some of this right here. Okay, so I've got -4 over 1 times 9/64. Okay, that's going to give me -9/16. So what I actually added to this side of the equation, or this part of the equation, is -9/16. And I got -9/16 multiplying -4 times 9/64. Okay, so I need to add the opposite of this to outside my parentheses. Okay, so I am going to add positive 9/16 to the outside because it's got to be the opposite of this right here, the opposite. Okay, now I'm in a situation where I can factor, and this is a perfect square trinomial by design. So when I factor this, I end up with x minus my 9, oh no, not 9, it's going to be minus my 3/8, okay? Because that's half of this right here, and the 3/8 is the square root of this, okay? So that's where I get that from, and that is squared. And then I need to add these two together. So we're going to go back to our fractions, and I have 8/1 plus 9/16. 16 is going to be my LCD. 8 times 16 is 128. Okay, and so then I'm left with 137/16. And that is my K value. So then I have 137/16. Okay, so this is Vertex formula for my parabola, and this is my vertex right here. Okay, and remember, our formula is minus. So this H value right here, I don't take this with me. I only have the 3/8. So my vertex is going to be 3/8 and then positive 137/16. Okay, and then if we look right here, this is just the decimal approximation for 3/8. So if we do 3/8 on our calculator, you should get 0.375, and we do. And then if you do 137 divided by 16, and that is a decimal approximation, you will get 8.5625. So what we say is our maximum, and we have a maximum because of that negative right there, and then you can also look at the graph. Our maximum is that y value. So our max is 137/16, and it occurs at x equals 3/8. Okay, and that is number 43 from 1.2. And if you struggled with that one, you are not alone. Lots and lots of people asked for that one. And this was a little bit more complex completing the square. because you've got your negative value here you've got to pull out, and then you've got an odd value right here that is not a factor of that -4. So you just kind of have to remember some of your algebra rules, and you'll be doing that a lot in calculus, is thinking back to your algebra rules. Okay, so then the next one that we're going to look at is a few from 1.6. The first one from 1.6 that we're going to do is number 23. Okay, and these are our log rules, trying to remember all of our different logs. So I need to simplify this. So I have 7 raised to the power of log base 7 of 29. Okay, now what happens here, and this is just one of our log rules, okay, if this base, so this is an exponent right here, and the base of this exponent is 7, and the base of this log is 7, okay? So I have 7 raised to log base 7. Because the bases are the same, they simplify out, and I'm just left with 29. So this actually equals 29 right here, okay? So, but the key here is that this base and this base have to be the same. Okay, the next one we're going to look at on that same page is number 31. Okay, number 31 from 1.6. We have the natural log of x to the 4th minus the natural log of x squared equals 2. Okay, so we have to think about our log properties, and when we have 2 logs that are being subtracted from each other with the same base, okay, and this is natural log, so that's base e. So I can rewrite that then as division of 1 log. So I have the natural log of x to the 4th over x squared equals 2. That does simplify to natural log of x squared equals 2. Okay, so these are our log properties. Now what I'm going to do here is I'm going to rewrite this as an exponent. So remember, this is natural log. Natural log means that your base is e. So I'm going to have e raised to the 2nd power, and that's going to equal our x squared. So think back to your log properties. So if I have log base a of x equals b, okay, that means a is our base. This is our exponent, okay, this is our base, this is our exponent, and this is our answer when I rewrite this as a log, or as an exponent, I'm sorry, it's already written as a log. So this is going to be a raised to the b power equals x, okay, and that's what we did right here. Natural log is base e, so I have e raised to the 2nd power, and that's going to equal x squared. Now, don't forget, when you take the square root here, you're going to have to do plus or minus. E is just a number. It's an irrational number, but it's still just a number. And when I take the square root of this, I'm going to get plus or minus e equals x. Now, you have to check this, because remember, we can't have negative numbers inside this right here. Okay, can't have negative numbers. So very oftentimes you've got to throw something out. But if I put negative e right here for x, and I raise negative e to the 4th power, I'm going to get a positive value. Okay, that's because I'm raising a negative number to an even exponent. Same thing happens right here. Negative e raised to the 2nd power, that's going to give you a positive number. So as long as I have positive numbers right here inside, then I'm good. And because I'm raising it to the 4th and to the 2nd, I'm good. So it is okay to have a negative number here because of this right here. Okay? Now, the next ones we're moving to is the chapter review. And this was number 9 on the chapter review. And what you were given is you were given this function right here on the chapter review. And let me just pull up exactly what you were asked to do on this one. Okay, so the first thing that you were asked to do is to sketch the graph of f of x plus 2. Okay, so f of x plus 2. That was the first thing that you were asked to do. And then the second thing you were asked to do is to sketch the graph of f of x plus 2. Okay, now this right here is going to affect our y value. Okay, it's going to affect our y value. So we're going to move the function up and down based on that. And it is true to value. Okay, true to value. So what I'm going to do here is I'm going to look at every single point and I'm going to move it up 2. So I'm going to take this point right here and I'm going to move it up 2. This point right here is going to be moved up 2. This point and this point. Okay, so then my new sketch is going to look like this right here, because this affects my up and down. When it is outside like this, it goes up and down. Okay, now this part, the second one that we're asked to do, this affects my left to right. This affects my left to right, and it's opposite. Okay, so if this says f of x plus 2, what we're doing is we're moving this 2 spaces to the left. So every one of these points is going to go to the left 2 spots. Okay, so everything's going to move this way. And so our graph that we're left with is this right here. And so I just want to pull up Desmos for just a second. Okay, I'm going to pull up Desmos just for a second and just remind you what that looks like and show you what that looks like on Desmos. So let's just take a function. Let's take x squared. Okay, so I've just got y equals x squared. Okay, x squared right here. So now if I take that function and I do y equals x squared plus 2, that just moves it straight up. Notice that that plus 2 is outside of that x. There's no parentheses there, keeping the 2 with the x. Now I can do the same thing, except I'm going to put the 2 inside the parentheses before I square it. So here I've got y equals x plus 2, and then I'm going to square it. And notice how it moves to the left. Okay, so I just want you to look at that and think about that, and that's just our translations. We're just moving the function around, and that's exactly what we were doing here. We were just moving this function around. We didn't have the function defined except by a graph. Okay, and so sometimes when we're asked to just look at the graph and move it around, it's a little bit more complex. Okay. Okay, so now we're going to move to number 13 on our chapter review, and we're talking about domain and range. Domain and range. Okay, so there's a couple of different ways that you can think about the domain and range. Oftentimes we go back to our parent function. So I've got f of x equals the square root of x plus 1. And a lot of times students do okay with the domain and they get a little bit more confused about their range. So my domain here, and that's what I plug in for x, is that whatever is inside this parentheses has to be positive. Okay, so I'm going to take my x plus 1, because that's what's inside the parentheses, and I'm going to set it greater than or equal to 0, because it's okay for me to have 0 inside the radical sign or the square root sign. That's okay. It can't be negative. Once it's negative, we get into imaginary numbers, and we're not gonna work with imaginary numbers right now. So here I've got x is greater than or equal to -1. So that means my domain here is going to be -1 to infinity. And notice that I put brackets right here. Okay, notice I put brackets right here because that -1 is included. Because if I plug -1 in right here, then I would get 0 and I would be okay. Okay, now, a couple of different ways that you can think about this for the range. Probably for this one, the simplest way is to just think about the graph of the parent function here. If I were to sketch the graph for this, for my parent function, the graph would just look like this right here. Okay, that's for my parent function. And so that graph right here is just the square root of x. So if I shifted this graph 1, okay, because I'm starting at -1, then it would look like this, okay? Would look like this. And so my range doesn't change. My range starts at 0. I don't move down into any of the negative values. And so my range for this one's going to start at 0, because remember, range is our y-axis, our y values, and then we are going to go to infinity. Okay, so that's my range. So I think for that one, just thinking about what the graph looks like is the most beneficial. Now, for 15, that's a little bit different. So 15, I've got f of x equals 2 over 3 minus x. And again, students, do okay with the domain. What the domain means is that we can't have a 0 in the denominator. So what I'm going to do is I'm going to take my denominator and I'm going to say 3 minus x cannot be 0. Okay, it's okay if it's negative, it's okay if it's positive, it just can't be 0. And then I'm actually going to end up with negative x cannot be -3. When I divide both sides by -1, I get that x cannot be 3. Okay, so our x can't be 3. So our domain is going to be -infinity to +3 and 3 to infinity. Okay, now my range, because if you think about the graph, and you think, well, wouldn't my range just be all real numbers? Because this is going to have a vertical asymptote right here. And so it's going to go to infinity in both directions. And that is a reasonable way to think about it, except that there is a value that is going to be excluded from the range. And the way that we find out that value is to use an inverse function. So if you remember, when we are talking about inverse functions, the range of my original function is the domain of my inverse function. So to find the range of my original function, I can find the inverse of this and find the domain of that. And that's how I would do this. So think back to your Math 112 skills. The way that we find the inverse function here is we rewrite this as y equals 2 over 3 minus x. Okay, I switch my x and my y, so then I have x equals 2 over 3 minus y, and now I solve for y. Okay, so I'm going to multiply both sides by 3 minus y. Okay, so I've got 3 minus y right here. And now I'm going to distribute that x. So I'm going to have 3x minus yx. You could write xy. It doesn't really matter. Equals 2. I'm going to subtract 3x from both sides. Okay, and then I'm left with negative yx or xy equals 2 minus 3x. And then I'm going to divide both sides by negative x. Okay, so then I have y equals, and I'm going to go ahead and rewrite this as 3x minus 2 over positive x. Okay, now don't start canceling stuff. You can't start canceling things. So let's just look at this right here. And this is our inverse function. So I'm going to rewrite this as f inverse of x is going to be 3x minus 2 over x. So the domain of this right here is that x cannot equal 0. Okay, that's the domain of my inverse function. Domain of my inverse function. So the domain of my inverse function is going to be the range of my original function. Okay, so then the range of this is x cannot be 0. Okay, so that's just remembering how we use inverse functions to make this work, okay? It's how we use inverse functions to make it work. Okay. Okay, let's move on to the next one. We are doing, so that was 13 and 15. Now we're looking at 17. We're looking at 17. Okay, 17. And this, again, this is on your chapter review. So 17 is wanting us to determine if the function is increasing, decreasing, in neither. And for a function to be increasing, it has to be increasing across the entire domain. For a function to be decreasing, it's got to be decreasing across the entire domain. Now, in calculus, we're going to look at a lot of places where we look at where a function's increasing and decreasing. But right now, we're just thinking about these graphs. And you will not be allowed to use Desmos on your test, but it's okay to use Desmos while you're trying to figure some of this out, because we got to kind of visualize what that function looks like. So what I want us to think about right here is our first function that we're looking at is f of x equals 3 to the negative x. So I'm going to rewrite this a little bit, and I'm going to rewrite this. And that's another thing we do in calculus is we do a lot of rewriting, a lot, okay? And the algebra that we use to do those rewrites is something that we just have to refresh ourselves about. So we do lots and lots of algebra rewrites, and then we use the algebra to clean stuff up quite a bit too. So let's look at this, 3 to the negative x. So I'm going to rewrite that as 1 over 3 to the x, okay? 1 over 3 to the x. So what I'm going to do now is think about what that actually looks like. So I'm just kind of moving that. Then I can rewrite it one more time, and I've got 1 over 3 to the x power, okay? So that's really the function that we're looking at right here is 1 over 3 to the x power. Now, if we were talking about like if we were talking about the function 2 to the x, that function is going to look like this right here, okay? That's what that function is going to look like. But what we have here is we have a base that's greater than 1. Okay, we have a base right here that's greater than 1, and so when we look at this right here, this is what we would call an increasing function. So that's 2 to the x. But what we have here is a fraction, something between 0 and 1 as our base, and that function is going to look opposite. It's going to look like this right here. Okay, and so this function right here is going to be decreasing. Okay, now if you need to go ahead and pop that into Desmos, don't hesitate to do that. That's okay. So you could either put it in as 3 raised to the power. Now, you're going to have to put that in parentheses right there. So you're going to have to do negative x in parentheses. Okay? And so that's what our decreasing function looks like. You could also do 1 divided by 3 to the x, okay, and that's going to be the same function. Or you could do 1 divided by 3. Whoops, you just got to make sure. There we go. Let's see if that works. I may have to get rid of that. There we go. Okay, so you could put them in any of these different ways. So it's okay to kind of remind ourselves what some of these functions look like, and that's okay. That's okay. Okay, now the next one that we're going to look at to decide if it's increasing or decreasing is we are going to look at f of x equals 1 over x squared plus 1. Okay, there's not really any rewrite or anything that we do here. We just have to kind of think about, okay, well, what does that parent function? The parent function there is going to be 1 over x squared. What does that parent function look like? And so we are going to stick in 1 over x squared, because that's our parent function. That's our parent function. And this is what 1 over x squared looks like as our parent function. Now, the function that we're looking at is just the same function but has a translation, and we've got x squared plus 1. And so that's going to move us, that is not the parent function. Okay. Sorry about that, guys. I gave you some bad information on that. And we'll talk more about those different kinds of functions and different things. But right now, we're just going to look at this graph. Now, remember, for a function to be increasing or decreasing, it's got to be increasing or decreasing throughout the entire function. And this one is not increasing or decreasing across the entire function. Okay? And so for this function right here, we're going to say neither, that it is neither increasing or decreasing. Okay? Okay, and the next one is going to be a parabola. And so we've got g of t equals t squared plus t. Now we know this one is a parabola because of that t squared. It's a quadratic. And if we think about what a parabola looks like, and you certainly can graph it if you want to, but a parabola looks like this or it looks like this. Okay, our end behavior for this one is going to be this because we've got a positive value in front of that t squared. So this one is also neither because it's a parabola. And for it to be increasing or decreasing function, it's got to be across the entire function. So if you wanted to look at that with a graph, okay, you could do x squared plus x, okay, and it's not increasing or decreasing. Now, it is decreasing until we get to the vertex, which is this point right here, and then it's increasing after that. But to be an increasing or decreasing function, it's got to go across the entire part. Okay, and then the last one we're going to look at is a cubic function, and it's g of t, t to the third plus t. Now, if you remember the behavior of a cubic function, it looks like this right here. That's the behavior of a cubic function. So this is going to be increasing across the entire domain. Okay, and that's because this has a positive value in front of it, and the behavior of a cubic function looks like that. But again, if you want to stick that into Desmos, you certainly can. And we're going to get x cubed, and I'm just using x because that's what Desmos asks us to use. Your problem does use t, but remember that t is just the variable. Okay, and so this is an increasing function. Okay. Okay, so that one is increasing. Now, the next problem I'm going to do is number 31. Okay, number 31. And number 31 asks us to find the solutions. Okay, find the solutions to this function and then sketch the graph. So we have f of x equals x to the fourth minus 4x squared. Okay, now one of the things when you are graphing or sketching the graph of these functions, you want to think about the end behavior. The end behavior. Now, this has an even exponent. So anytime our largest exponent is even, the ends of our function are going to go both up or they're going to go both down. Okay, that's our end behavior. We don't know what it does in the middle, okay, but our end behavior is both up or both down. Okay, now we decide if it's both up or both down based on whether or not the number in front of this is positive or negative. Okay, and because we've got a positive 1 right here, we know that our end behavior is going to look like this right here. We don't know what happens in the middle, but that's what our end behavior is going to look like. Okay, so I'm going to just do a little sketch. We're going to have our end behavior, and those squiggly marks mean we don't know what it's doing in the middle. Okay, so now we're going to find our zeros, and to find our zeros is we just set it equal to 0, and then I have x to the fourth minus 4x squared. Okay, I'm going to factor out an x squared, and then I'm left with x squared minus 4. That's a difference of perfect squares. So I'm going to have x squared, x plus 2, x minus 2. Okay, I'm going to set each one of these equal to 0. And so my x can be, oops, sorry about that, x minus 2 equals 0. So my x can be 0, my x can be negative 2, and x is positive 2. Okay, now those are my zeros. Now, this one right here has a multiplicity of 2. That means it occurs twice because I've got that x squared. So that's another one of those things, a multiplicity of 2. Okay, it shows up twice. So that means that whenever I hit this 0, I'm not going to cross it. I'm going to hit the x-axis, and then I'm going to go back in the other direction. That's because it has a multiplicity of 2. Okay, here and here, I'm going to cross the x-axis. Okay, but at 0, I'm just going to bump up against it and then go back down. So let me draw our graph right here. Okay, and I'm going to do 1 right here. I'm going to make it a little bit more just so we can. Okay, so that right there is going to be 1, or negative 1, and this is going to be negative 2. This is going to be positive 1, and this is going to be positive 2. Okay, now we have a 0 at negative 2, at 0, and at positive 2. And we know from here we're going to go up. Okay, we cross the x-axis at negative 2 and positive 2. Okay, we don't know how far down we're going, so that's something that we're going to learn how to do in calculus. Okay, and then we're going to go up and we're going to bump that. And that is because of the multiplicity of 2, because we've got x squared equals 0. That's why we bump right there. Okay, that's how we think about graphing that. Okay, now the last one I'm going to do is number 43 from the review. Okay, number 43 from the review. And this is composition of functions. So this has f of g of t. So f of g of t, and that equals 12t plus 9 to the 4th power. Okay, another way this could be written is f composed of g of t. Okay, and you know that's composition of functions back from Math 112. So basically, what you're wanting to do is you're wanting to define what f of t is, and then what g of t is. That's what you're trying to do. Okay, so this part, the g of t is going to be the inside. The g of t is going to be the inside. Okay, so our g of t is going to be 12t plus 9, okay, because that's what's on the inside. We are decomposing this function. We're doing the opposite of composition of functions, okay? We're just doing the opposite. Then our f of t is going to look at this right here as a unit, okay? We're going to use the same variable. This right here is what we're going to take out. What are we doing to this right here? And what we're doing is we're raising it to the 4th power. So we're going to have t to the 4th power is what we're going to have right there. Now, you're going to work backwards and see if this works. So to do f composed of g of t, then what you do is you take g of t and you plug it into f of t. And so we have to make sure it works. So if I take 12t plus 9 and plug it in for t, will I get my original? And we do. Okay, so my answer here is this, that f of t is t to the 4th and g of t is 12t plus 9.